Getting started in RobotStudio. In this video, we're going to go through how to work with a simulation within RobotStudio. We're going to import some objects from SolidWorks. We're going to import a robot or two from ABB. We're going to talk about how to manipulate them around in the environment. And we're going to add a controller to the simulation as well. Let's get to it. When you first come to RobotStudio, you're going to see a screen like this. And before we get into actually creating our first station, I want to go through a couple of quick terms. Those terms are the station, solution, and virtual controller. So first, what a station is. In RobotStudio, a station is your virtual environment and all of the items within it. So it's essentially what RobotStudio calls your simulation. The solution is a file structure that's created within your particular operating system that controls and contains all the various files that are used by your station. And finally, a virtual controller is a virtual representation and a virtual copy of a real world controller that allows your robot to be able to be manipulated and function as though it would in the real world. This being said, RobotStudio gives us three different options of files that we can create. We can create a solution with empty station. We can create a solution with station and virtual controller, or the one that we're going to start with now, which is creating an empty station. And we're actually going to, by the time we're done in this tutorial, have a solution with station and virtual controller, but we're going to create it all from scratch. So go down to empty station here and hit create. And then you're going to come to a screen that looks like this. This is our main RobotStudio window, and we start off on the Home tab. Down the left-hand side here, we have the Layout tab, which shows every object that you have in the center window, which the center window shows your actual simulation environment. And then on the right-hand side here, we have a search pane that allows us to search through either the station, every one of our referenced documents or libraries, and try and find components that we may want to bring in or import or export and manipulate within the simulation. Down at the bottom here, we have the output window. The output window actually gives you a variety of different information about what's going on in the simulation at that given point in time. And it can be a great diagnostic tool to know what RobotStudio is doing. So at this point here, I'm going to clear my output window so that I know everything that's happening within my simulation at this point in time. So I'm going to right click and say clear. Now I've got a cleared output window, and we can get into working with the first object. So when it comes down to working in simulations, the most important kind of item within RobotStudio, besides of course having a robot to do something with, is a geometry. And what we're going to do here is we're actually going to start off by importing custom geometry that I've made outside of RobotStudio. I made a frame in SolidWorks, and we're going to import that into RobotStudio. Now, here's the thing to note when it comes down to creating something to be able to be imported into the software here. The most important thing to note when it comes down to creating a model that you're planning on importing into RobotStudio is that the Cartesian coordinate system in RobotStudio is a little bit different than the default coordinate system within your particular CAD package. So in SolidWorks, for example, the vertical direction of SolidWorks is actually the x-axis. Well, in RobotStudio, and as you may know with working with robots, that the z-axis is vertical in RobotStudio. So you need to keep that in mind when it comes down to creating your object if you want to simplify the import process. We can manipulate these objects around. However, we're not going to be doing that in this video. So just keep that in mind when it comes down to creating an object, that to make it easy for import, you want to make sure that the Z-axis is up. So you build everything off the Z-axis so that you know that it's going to import by default in the right orientation. The other thing to keep in mind is wherever your origin of your 3D model is, that will automatically import at world coordinate 0. So for ease of use within this particular simulation, I have created our IRB 360 frame. This is the frame that we use to mount our robot. And as you can see, I've created the origin point at the front of the base of this robot, or of the robot frame, sorry. And this makes it way easier to bring it in and have it show up in the correct location within my simulation. Now, as you may notice, it's imported this object, and the object is way larger than my current frame. So if I want to zoom out to view this, one way to do this is we can use our scroll wheel, and we can scroll down to zoom out and scroll up to zoom in. If we want to pan around, we can press and hold Control and right click, and we can pan left and right and up and down. If we want to rotate, we use Shift, Control, and right click, and we can pan and rotate around a various item. Now, none of these really helped me to get this object into my view completely. So the easiest way to do this is inside your simulation window here, you're going to see this View All. When you click on View All, it will automatically zoom out and pan everything to sit within your current view window. This is an easy way to see absolutely everything that you've brought in to RobotStudio. Everything that we bring in is essentially a geometry within RobotStudio, including items like libraries. So what we're going to do now is I'm going to hide this frame that I brought in, and I'm going to right-click on the frame, and we're going to go to Visible and uncheck Visible, and that makes it hidden. If I want to see it again for a temporary period of time, I can select it from the layout view down the left-hand side here, and it'll show up, and as soon as I deselect it, it disappears again. This makes it easy to manipulate a variety of different other objects within our simulation. So the next thing we're going to do is we're going to take a look at the import library. Now you'll notice that we've got two different types of libraries here. We've got the import library and the ABB library. The main difference between these two is the ABB library is specifically for ABB components, and it contains all kinds of robots and positioners and tracks that you can purchase directly from ABB. That's all it contains. The import library contains your user library, so custom library components that you've created. It creates or contains the student libraries, which is currently empty because I haven't built our library components that are available to our students. And it contains the equipment library, which is by default created by ABB, and this brings in a variety of different equipment that you can work with and simulate in your environment. So the thing that we're going to bring in from the equipment library here is we're going to bring in an IRC5 compact controller, because that's the type of controller we use with our IRB 360 robot, which we're going to import in a few minutes here as well. Now, here's the thing to note. When I bring in this controller, I really am cautious to say that I brought in a controller when it comes down to working with RobotStudio, because realistically, there is no actual controller in the simulation yet. This is just a virtual representation of the box that is the physical controller in the real world. So at this point, I still can't drive my robot. I still can't manipulate it as you really would when it comes down to a real robot, because there still is no controller. This is literally just a 3D model for reference purposes so that we know what's physically laid out where, and we can make sure that when we bring in our robot, that it's not going to collide with other objects within the work cell. That's one of the big benefits to RobotStudio is you can build a virtual representation of your real world factory and manipulate layouts and test out programs without actually going to the real work cell, taking it offline and manipulating everything around. So let's grab a hold of this robot or this controller, and we're going to move it to the approximate location that it exists in our real controller within our lab, or our real layout within our lab. So there's a variety of ways that we can move around an object. And actually, before we do that, let's take a look at how we can change our view and work with this a little bit easier. So I'm going to click on my controller, and you notice I get this little white crosshair here. When I press this view center, it's going to center wherever that little crosshair is in my view window. And when I zoom in, it zooms in on that crosshair. When I press Control and Shift and right click to rotate, it rotates around that crosshair. So it makes it very easy for me to see and manipulate around an object. I'd encourage you to spend some time when we're done this video going through a couple of the simulations here and playing around with them to get used to panning and zooming and selecting objects, etc. So let's move this to its actual location. There's a variety of ways that you can do everything in RobotStudio. In these videos, I'm going to go through some of the most effective ways to do things and set them up. And I'm going to use those most effective ways for the majority of the tutorials. However, at the moment here, I'm going to show you a couple of different ways that we can move and manipulate this item. So we're going to click on up here in freehand, and I can click on rotate, and I get the ability that I can rotate this object around. You can see as I select this Z, the blue arrows here, I'm able to rotate my item around the Z axis. I can rotate it around the Y axis, or sorry, rotate around the X here. And if I grab the green arrow, I can rotate it around the Y. And now I have a really messed up position on my controller. So that's definitely not what I want. So let's put it back to its default position. One way that we can do this is we can go into position by right-clicking on the item, go to position and rotate. And I want to rotate actually, you know what? With my rotate here, I'm not sure that I can easily rotate it back because of the way that I did this. So let's just grab this controller here and, well, let's try one other thing. Let's try set position. There we go. When I go to set position, you can see down here I have my orientation in degrees. If I zero all of these, and say apply, now my controller is back to my default location. I can also freely drag by going over here and saying move, and then I can drag my controller around. But of course, that's not an optimal way of moving things around. So let's move this in the optimal method. The optimal method to do this is to right-click on the controller, go position, and set position in this case. And the thing that I need to do is I need to make sure that I have the right reference selected. And we'll take a look at a couple things about this moving here. So when I take a look at this, I've got set position is the command that I'm using. And then I've got IRC5 compact. This item here, this IRC5 compact, you might need to make sure that whatever it says up here is the item that you intend on moving. Because if I select my ABB frame and now I pick a position to move it to, so move to 100, I am now going to move my frame instead of my compact controller. So you need to pay attention to what it is that's listed up here, especially when we're moving an object within reference to another object. That'll come in this video a little bit later on. So what I want to do here is I want to rotate this controller. Actually, no, I'm not going to rotate it yet. I'll do that with the rotate command in a minute. I'm going to move it approximately 1500 millimeters or 1.5 meters in the X. I'm going to move it approximately 1 meter in the Y, and I want to move it approximately half a meter up. And we're going to say apply. And then we'll view all so we can see our controller. There we go. Now our controller is approximately in the right location. However, it is not rotated the right direction because the front of my controller actually faces out in line with the x-axis of our robot. So let's change that. So we can right-click on the controller, go to position and rotate. And I'm going to rotate around the z-axis by 90 degrees. And the thing that we need to keep in mind when it comes down to rotating an object or positioning an object using the set position is we need to pay attention to what the reference is. So right now, if I do a rotate in reference around the Z from world reference, notice right now this frame down here is kind of bolded and selected. When I do this, it's actually going to take this controller and plunk it down over here somewhere because I'm rotating 90 degrees around my world coordinate. So let's see what that looks like. So now that's not where I want my controller. So I'm going to hit Control Z and undo that. And we're going to go back into rotate. And instead, what I wanted to do is I did want to rotate around the Z, but I wanted to grab the local. And you'll notice now the frame around the controller itself is what's glowing. So now I've got the right frame selected. I can rotate my controller 90 degrees and we're good to go. That's where I want it. Now, the other thing that you want to keep in mind when you're doing this is in a lot of these controls, if you hit enter a couple times, it doesn't escape out. It actually applies that same rotation over and over and over again. So you can actually end up with your controller in the wrong orientation, or your object in the wrong orientation from what you actually intended. There's a couple ways to get out of this. You can either hit close or you can hit the escape button on your keyboard, and that will get you out of that particular manipulation instruction. So now we've got our controller in approximately the right place. I'm going to bring in take a look at my frame, and yeah, that looks about right for how my setup looks in our robotics lab. So that looks pretty accurate. Do a little bit of zooming or rotating around here. Yeah, that looks good. So I'm going to deselect my frame and my frame disappears again. And now I'm going to bring in a library component. Now the first library component that I'm going to bring in is actually not a robot that we're going to use in the simulation. I just want to bring it in to illustrate a few things. So I'm going to go to my ABB library here and I'm going to grab let's grab a IRB 140 because we have some of those in our lab. So there we go. We're going to grab the IRB 140. And the one that we have is we have the IRB 140. We don't have the 140T. The difference between these two variants is the 140T has a specific trim package for bringing in a variety of different mounting points for various hardware to be installed. We have just the simple 140, and we've built all of our own components to tie to the robot. So we're going to just say OK. And here we go. We've got an IRB 140 in our simulation. Let's do a view center. View center on the robot, and we're going to zoom in. And here's our robot controller. Or a robot, not controller yet. So this is a 3D model, and the important thing to note about bringing in a library component when there's no controller in your station is that this component is literally a dumb component at this point. And when I say a dumb component, I mean we can't manipulate it in a jogging fashion that would be conducive to a typical setup. So I'll show you what I mean right now. We go to freehand jog, and we're going to jog by joint. We can grab a hold of all of our joints, and we can move this down to 110 degrees. We can move this all the way back to negative 90 degrees for joint 2, which is normal. That's what you can do with a robot. And you'll notice it's punching through what looks to be the floor. Just a quick note, this is not a floor. There is no floor. That is actually the user coordinate system that it's moving through, and we'll talk about that more in another video. But the thing to note here is we essentially have a 3D model with a joint or a mate and a constraint. And this is better illustrated when I take joint 3 here and I move joint 3 down to 50 degrees, which is its physical limit. And then I grab joint 2 and I'm going to move joint 2 down to its physical limit. And you notice when I do this, the 3D model punches right through itself. Now, this can't actually happen in the real world because the robot controller has software limits. And of course, in RobotStudio, we also will get those software limits, but only if we have a controller set up and tied to the simulation. At this point, this is a dumb model. It is literally a 3D model with constraints that allow each axis to move in a specific number of degrees, and that's all you can do with it. There really isn't much else that you can do with this model at this point. You can't go in and you can't jog it like you normally would. So that's one of the limitations when you don't have a controller tied to your simulation. Now, if I want to put this back to its original position, I can go right-click on the controller itself, go to Move to Pose, and Jump to Home. And this puts your mechanism, which is essentially what this robot is it's a mechanism at this point, puts the mechanism back to the quote-unquote home position. So this home position is created when you define the library component in the first place. In a future video, I'll go through how to create library components, and then you'll see how all of these different types of things work. But for now, that's all we're going to do there. Now, we don't actually want this robot. As I mentioned before, we're working with an IRB 360. So we're going to right click on this. We're going to delete that robot because that's not the robot we want. And we're going to go to our ABB library, grab the IRB 360, and the variant that we have in our lab is we have the 1130 millimeter range, and we have it in a 3 kilogram variant, I believe. Double check with your lab, it will outline which variant we have. And we have the standard configuration. Now, when I say standard, this robot comes in a washdown, stainless, 3-axis washdown. The one that we have in particular is the standard. So we're going to say standard and OK. And you'll notice the robot imports, and it looks like it's imported through the floor. But again, this grid is not a floor. This is the user coordinate system, or the UCS. And the user coordinate system, when you by default create a RobotStudio simulation, is synchronized to the world coordinate system. So what we want to do now is we've got this robot. We need to bring our frame back into being visible. So we're going to turn on visibility on our frame, and we're going to move this robot up onto our frame. Now, before we do this, I'm going to zoom out, and we're going to take a look at how we can grab different items within the frame, because this will make it a lot easier to place this robot where we want it to be. So with a 3D model, like our frame here, let's hide the robot just for a few moments. With a 3D model like our frame, we can use these different tools here to change what it is that we're selecting. The very first thing that it comes onto is it comes onto the part selection. When you have part selection highlighted, you grab an item, it grabs the part level of that item. So it will grab the whole part. If we go down to body selection, I can grab an individual body like this tube. This tube is an individual body within the imported part that I brought in. And going down one level further, we can go to surface, and we can select an individual surface of a body of our part. So this makes it easier to pick what you're going to grab a hold of within your simulation. We can also have snap points. So when it comes down to aligning items, sometimes we want to be able to snap, to the midpoint or to the center of a surface or to an edge or to a corner, things like that. So that's where we come into these snaps. We've got snap object. So this will just snap somewhere within that object, any of the typical snap points. We've got snap center, which will snap the cursor to the center of whatever it is. So here I've got snap to the center of the surface. If I go snap to center of body, we're going to get the center of whatever body surface I'm pointing to at that time. So I'm going to leave it to snap to surface. We can go snap mid, which will snap to the midpoint of an edge of the surface. We can say snap end, which will jump to the closest end point that I'm pointing to. We've got snap edge, which will snap anywhere along that edge. So if you're just trying to grab an edge to align to. When we have a part selection, we can use snap gravity, which will grab the center of gravity of an object based on the mass properties that you've told it about this frame. So this is a little bit of a weird thing to work with, and there's a lot of setup that you need to do with your particular object before you bring it in. so that you can make sure that this center of gravity works properly. You can also turn on Snap Local Origin, which will snap to the local origin of the object. And you can say Snap Grid, which will snap the cursor to somewhere on your user coordinate system grid. What we're going to do for this portion of the exercise is we want to snap to surface, and we want to snap mid because, or sorry, snap center, because we want to take this point here on our robot, the center of this mounting hole, and we're actually going to take the center of that mounting hole and we're going to put it in line with the center of this hole in my frame, because these holes are designed for the mounting tabs. So let's go about doing that. We'll zoom out, show everything, and we'll put my mouse cursor at the center of this. We'll select our robot because that's what we want to move. We're going to right-click, position, and we're going to use the place function. And because the robot is already in the right orientation, we're just going to place with 1 point. We're going to say place 1 point. I'm going to grab the surface because I want the center of this surface here, and make sure that we have our cursor in the primary point, the from point. I'm going to select this, and then I'm going to use Control and I'm going to zoom out. I'm going to use my Control function to drag around. I'm going to grab a hold of my frame here. I'm going to view center on my frame. Sorry, I'm going to click over here, view center on my point. I'm going to pan around to the underneath side because this is where I want it to tie in. And I want to select the center of that hole. So in order to do this, right now, if I select the center of this hole, you'll notice that the primary 2 point does not change. The reason it doesn't change is because I didn't have my cursor there. So if I put my cursor in here and I again go in and select this point, it'll say that it's going to move from here to there, and you can see a green line show up. If I pan around a little bit, you can see the from and the to, and the green line connects those two. We're going to say apply. And now we've got a problem that happened. The problem is, you'll notice that my frame moved. Remember earlier on I said that we need to watch out what we have for the object selected? Well, I didn't watch what I had, and now I've moved my frame. So let's undo that operation. Let's reselect those points and make sure that I have my robot selected as the item that I want to move. So while we've got our frame selected, I'm going to do a view center, pan around. I'm going to grab my 2 point. The cool part about this is it doesn't matter which one you grab first, the 2 point or the from point. I'm going to select my robot and view center. Zoom in a bit. Grab that surface. And I've got my from point on my robot. My 2 point is up on my frame. That's what matters, is where the from point is and the 2 point is. And we need to make sure that, again, my place object, what I'm moving, is the IRB 360 and not the frame. Otherwise, it would have offset the frame again. So now when I hit apply, there we go. My robot is now in place on my frame as I would expect. And there we go. That's a robot installed on a frame in RobotStudio. So the next thing that we're going to do, and the final thing, is we're going to turn on our virtual representation of our controller make sure our work cell looks about like what we would expect. It does. And then we're going to save this. So to save this, I'm going to hit this save because I haven't saved my station yet. And I want to save this on that folder on the desktop that we referenced to in a past video. So I'm going to go to Desktop, RS Video Demos, Solutions. I'm going to create a new folder, and I'm going to call this Getting Started. And inside my Getting Started folder, I'm going to call my file Getting Started because that's what I want to call my station, and hit Save. There we go. We've saved it. Now the autosave function would work. Beforehand, if I hadn't done this and the software crashed, I could run into some real headaches because I would have lost everything that it was that I was doing. So it might be a good practice when you go to first create a station, immediately save it and move on from there. So we've got this created. Now we're going to go in and we're going to do the last step, which is bringing in a virtual controller so that we can manipulate this robot around properly. So what we want to do is we're going to go over here to Virtual Controller, and we're going to use this really cool feature called From Layout. Now what the Virtual Controller From Layout allows us to do is when you open it up, you're going to get this dialog box. We're going to give the controller a name. I'm going to call this IRB 360. And you'll notice I get this exclamation mark. That's because I have a space in the name. You can't put spaces in the name. It's an illegal character. So I'll change that to IRB underscore 360. I'm going to change this location. Now, this is one of the things that gets done automatically for you when you create a solution with station. So I'm going to go in here, and because I didn't create a solution, I need to now go in and find that folder. I'm going to go Desktop, RS Video Demos, Solutions, Getting Started, select the Getting Started folder, and it's going to create my station there. You want to select the version of RobotWare that you use for your particular systems. In our case, this is 6.10.02. I'm going to say Next, and it's going to search my layout for any particular robots that are in there and say, hey, I found this IRB 360. Is this the one that you want to tie in? And I'm going to say yes, and Next. If you want to add any additional options, unlike in a real robot where you have to pay for all of the options that you want to install, this is a virtual robot. You can play around with any options and configurations and then send that information off to ABB so that when you order a robot, you get those options. We're just going to leave these as default, and we're going to say Finish. And then now we're going to get this little controller status pop up. And you notice this controller status 0 of 1 shows up down in the bottom right. This is how we know that we've got a controller showing up in our simulation. Right now, we've got this notification down here saying creating virtual controller. We've got a progress bar, and it says the station controller is IRB 360, and it said starting, and now it's started, it's up and running, and we have this green indicator down here telling us the controller is there, it's online, and it's ready to go. So at this point, we now get those jog linear options and jog reorient options. So we can click on jog linear, grab a hold of the end of our robot, and now we can move the robot and manipulate it around as though it was a real robot. Once we're done, we're going to save this, and that's it for this tutorial video. Feel free to grab some other items, bring them in, manipulate them around, and get used to and familiar with navigating around items within Robot Studio. And we will see you in the next one.